The taxonomy of the primate order consists of two suborders, Strepsirrhini and Haplorhini. These classifications help scientists place primate species in a particular point in evolutionary history. This display will help distinguish the features of these suborders using 3D scans of real primate skulls. Strepsirrhini. Strepsirrhines are commonly referred to as the lower primate since they retain the most primitive traits derived from their mammalian ancestors. Strepsirrhines include the lemurs of Madagascar and the lorises of Africa and Asia. All strepsirrhines share a number of derived traits which categorize them in the suborder Strepsirrhini. Many of these traits are visible in the skull. Generally, strepsirrhines have smaller brains relative to body size. As seen on the ring-tailed lemur, strepsirrhines tend to be smaller than their haplorhine counterparts. Strepsirrhines are categorized by their wet nose or rhinarium. Their relatively long rostrum is the result of a large olfactory bulb, giving them a highly developed sense of smell. Due to their primary reliance on smell, most strepsirrhines have a decreased dependence on visual input. As you can see on the Sunduslow loris, their eyes are forward-oriented but placed more laterally to the side of the face. Strepsirrhines also have wide-set eyes, a common trait found in nocturnal species. Their large eyes allow these primates to see in dark conditions. Another unique trait that distinguishes strepsirrhines is called the dental comb. Found on the mandibular anterior dentition, the lower central incisors and canines stick out at a 90-degree angle from the rest of the teeth. These modified teeth are a derived trait related to the strepsirrhine grooming and feeding behaviors. You'll also notice that strepsirrhines have what is called a post-orbital bar, a feature where the zygomatic bone and the frontal bone join to form a ring that runs around the eye socket, but leaves the rear of the eyeball unprotected. As you can see on the Sunduslow loris, strepsirrhines lack a thin wall of protective bone behind the eye, preventing them from having complete post-orbital closure. Strepsirrhines are also known for their unfused mandibular synthesis, which divides the jaw into two halves instead of one fully fused bone. Haplorhini. Commonly referred to as the higher primate, haplorhines consist of two infraorders, tarsiers and anthropoids. Anthropoids are further divided into two parvorders, platyrrhines, the New World monkeys, and catarrhines, the Old World monkeys. This is the suborder to which modern-day humans belong. In general, haplorhines tend to be larger in size, and their brains are larger than the strepsirrhines, resulting in a larger skull easily seen in the gorilla specimen. Since they tend to be diurnal, haplorhines have a short rostrum and small eyes, which show an increased reliance on vision and a reduced reliance on smell. Haplorhines are further distinguished from strepsirrhines by their facial features. As you can see on the face of the gorilla, haplorhines show a trend of flattened faces with forward-facing eyes. Unlike strepsirrhines, haplorhine primates have evolved fully enclosed eye sockets as seen in the gorilla and the tarsier. The haplorhine dental configuration does not include a dental comb nor lower caniform incisor. However, many do retain a honing chewing complex, and with the exception of tarsiers, the lower halves of haplorhine jaws are fused together. There was some debate to whether the tarsier infraorder belongs with haplorhines, as they exhibit features from both groups, but for now, their taxonomy remains with the haplorhines. The taxonomy of the primates is always being refined as new information is found or new insights are gained. The Haplorhini and Strepsirrhini suborders help place a species on the evolutionary tree, giving anthropologists and other scientists a clear picture of the evolutionary history of not only modern primates, but humans as well.